So here it is, northern. It is 33 degrees. It's supposed to be on its way up to 36, like I put in the description. But here's the chemical snow. Yeah. Anyway, you know, if you can see me, I'm gonna go over here to the fireplace. But so I put a grand solar minimum. Oh, I'm losing my train of thought. Oh yeah, grand solar minimum, global warming. Okay, so the grand solar minimum stuff. For me, if everyone remember the intensity of the heat throughout this last year and the year before as well, but especially this last year, last summer, intense heat, a lot more UV. Okay, to me, I just say it plain and simple. To me, the sun is not, of course, 93 million miles away. It's only gotten a bit closer and closer year after year. At least I've noticed for like 3 years. And I watch the change, of course, as the sun changes its course from the ecliptic further north on the ecliptic during our winter or summer to further south, moving across the ecliptic like now as we're coming into winter here in the northern hemisphere. So with the grand solar minimum thing, and they talk about, of course, yeah, there's more sunspot activity and this and that, and except they spin the grand solar minimum as a way to make it seem like we're going into an ice age. Well, if we remember, no, the heat and everything was a lot more intense, and actually these buds and the trees and the plants out here are still trying to bud because there's enough energy coming through. It's more intense energy. There's more. So does that mean it's global warming? Well, for me, I'd just say that plainly too. That no, it's not a globe. So anyway, it is warming because the intensity, well, of the sun is more intense because it's a bit closer above us, getting a little bit lower maybe. But that's just my opinion. I did, however, observe the change in heat and the increased UV, A, B, and C over the last couple of years, and this last year was most intense. And were all that stuff not to be up there right now in the sky? All these chemical compounds that then suck in the heat around them to create this crap, this stuff. That then is, of course, the frequencies go along with this. But this is not. This is not natural snow. This is that thick chemical stuff that just sticks to things. It doesn't just fall. And it's not because it's wet snow because of the temperature. Because if that was the case, none of this would be frozen. This would be rain. So, and it sticks. See, folks, remember this difference too on the cars because it's dangerous. You gotta make sure you have an ice scraper early because this stuff, the way it sticks to things, it'll stick right to the windows and freeze on the window itself. So normally where you'd be able to wipe off some stuff that might have come down and caught you on the road or something pretty quick with wipers, this stuff, see, were it to be just a touch colder too, this would be frozen just in these little spots of like raindrops as they fall, and they just freeze instantly. So this stuff is it's really it's much more dangerous than actual real just snow made of water. You can hear a plane going over now. One of those big planes high in altitude that puts out those big plumes because, I mean, here it is. They've been working on it and now it's coming. Now this stuff is all stuck to me all over the place. This gunk. Anyway. Well, I just wanted to point that out. And this stuff is, it's a lot more dangerous because it's a lot more slick. It sticks to the roads. It sticks to the ground, obviously, where the ground is not cold enough even for it to stick. But it'll stick. And yeah, the wind is picking up now. With the wind, that can freeze on the roads real quick. And it is so so much more slippery than regular snow that yeah, I just can't say how important that is. Real important to be real careful in that stuff. So anyway, yeah, I'm gonna go for now. Warm up, get this gunk off me. But I just wanted to point this out once again, or at least try. So, all right, thanks for watching, listening. Feel free to share. Talk to you later.